So today we're going to learn about how to use level order, breadth for search, right? So how to code level order. And before we code that, uh, we have to understand the concept of it. Okay, let's look at the diagram right here. On the left side, we have a DFT, depth for search. On the right side, we have breadth for search. Well, today we're going to learn about breadth for search, right? So the depth for search is basically digging in deeper and deeper on the leftmost and traversed all the way through on the rightmost. On the right side, we have reverse search for going left and right, and then left and right in the triangle uh, directions, right? So why is this useful? This is the most efficient way to traverse in binary tree, and this is really good for finding the shortest path, right? Something like we can use it for Sudoku and also for flight scheduling flight for the shortest path and something like the shortest something for we can use it for the shortest path, right? So this is why breadth for search is very useful. Okay, let's code this on JavaScript, and before we have to understand how it works. So right now we're going to use Q and then shift. So Q is basically first in first out, and shift allow us to do exactly that. Shift is a JavaScript built-in that we can remove from the first, right? So we're gonna push the root on the Q, right? And then that one will be shift or remove from the queue itself right away. And after that, we're going to the left, check if it's empty. If it's not empty, then we're going to store it on the queue and push it on the queue. And then after that, 6. And yeah, so the first one was we removed the 5 already, so 2 will be the first one. So index 0 will be 2. So and then we're gonna shift 2, no 2, and then push it on the answer and the answer array. So yeah, so it will repeat something like this in this manner. So 5, 2, 6, and then yeah, so it will repeat over and again for this binary tree. And that will be our level order breadth for search. And also we can use reverse order, which is basically the same principle going from left to right and to right to left. So it's going to be right to left for reverse level order. So it's basically same principle, but it's going to be reverse order. So yeah, let's go and code this on JavaScript. This dot level order, and then we're going to have a functions, but we're not going to pass anything here. So, and then we will have a variable called answer, and that will be array, and we will have Q, and it will be empty, and we will store this dot root, and we're going to return answer. That will be answer. So spelling mistake can ruin everything. All right, and then we're going to push q dot push no here, and after that if check if, well, before we push that, we'll have to check if no is empty. If it's empty, then we're going to return null, basically indicating that the binary tree is empty, so nothing's to traverse. All right, and after that, we're going to have for a while and check if the queue length is greater than 0. If it's not greater than 0, then we will escape. So that means queue is empty. Okay, so after that, we will have to shift dot shift. Well, yeah, so q dot shift, and we will be on the node and check if we will have to push it on the answer, right? So node dot value, and after storing that on the answer inside in the answer array, we will have to check if uh, node dot left is empty, right? And if it's the tree is empty on the left children, and if the left children is not empty, then we will have to push it on the queue. Node dot left. Okay. And if node dot right is not empty, we will have to push the right on queue. And I think that's it. So yeah, so as you know, this left and right is basically what we did right here, left and right. Okay, and then the answer will we remove the root. Well, first we check if it's empty, and if it's empty, then we will return null. And if it's not empty, then we will push the root, which is 5, and then we will check if the length is greater than 0. If it's greater than 0, we will remove the node, the first node, which is 5. So that will be move it here, and then we will check the value, and we push it on the answer. And first, that will be 5. And after that, we check the left side of the node, right, and the right side. So when we shift this, we are shifting, we are removing a node, right? A node, but that node is linked to the tree. So that's why we can able to check the left and right, like we did right here. Okay, so let's try and test control enter. As you can see right here, it worked perfectly, right? Level order must be working empty, right? And also for returning the array correctly. All right, for the reverse one, let's copy this and paste it down here, and then we're going to copy this and copy here. Now it's going to be basically the same concept and the same coding, but we're going to turn from right to left. Okay, so it's going to be, instead of here, we're going to go first go right to left, and right to left, and right. Okay, so that's basically the answer for reverse level order. All right, control and enter, and as you can see, it worked as according to our plan. And yeah, that's the answer for breadth first search.